2014. 2014. 30-second question. This is going to be the first diagram. This diagram they have given. This is the diagram given. Now, under equilibrium, we studied three categories. First category is equilibrium of forces, equilibrium under two forces, equilibrium of a body under two coplanar forces. Second category, equilibrium of a body under three coplanar parallel forces. Third one, equilibrium of a body under three forces that are not parallel to each other. Here, we can apply the third category. Third category can be applied. In second one, three forces. Are they in the same plane? Yes. Are they parallel to each other? No. Now, what is the second category? Equilibrium of under three coplanar parallel forces. No. Here, all the forces are coplanar to each other. They are on the same plane, but they are not parallel to each other. F1 is parallel to F3, but F2 is not parallel to F1 or F3. Therefore, this will be discussed under third category. Third one, they are also F1, F2, F3 are on the same plane, but F3 is not parallel to F1 or F2. Therefore, this will also be discussed in the third category. Fourth one, the forces are not parallel to each other. They are on the same plane. They are not parallel to each other. Therefore, this will also be discussed under third category. Okay. Before seeing the first question, you see the third question, first question, the first choice they have given. You can see the forces are on the same plane. F1, F2, and F3 are on the same plane. In third category, what are the conditions that should be applied? Three forces must be coplanar. Here we have all are coplanar. Line of action of three forces must meet at a common point. F2 is meeting, F1 is meeting, F3 is meeting at this point. Therefore, F1, F2, F3, all the forces meet at the same point. Second condition, first condition is satisfied, second condition is satisfied. What is the third condition? Resultant of any two forces should be equal in magnitude and opposite in direction to the third forces. Yes. Here, the resultant of F1 and F2 will be equal to F3 and opposite to F3. Now, if I take this component of F1 and F2, now they have said F1 is equal to F2. No, they have said in the question F1 is equal to F2. Now, let us take this as 10 Newton. Now, let me take this as F1 also 10 Newton, F2 also 10 Newton. Okay. Now, I can separate this F1 into x-axis and y-axis. Let me separate this into component. Let's take this as 5 Newton and this as 5 Newton. If I separate this into component, and I can also separate this force into y component. It is x component, that is y component. That is going to be 5 Newton. This 10 Newton is going to be classified as 5 Newton and 5 Newton. Okay, we are going to take component of this F2 force. We are going to take x component and y component. This 10 Newton will be divided between the x-axis and y-axis. Likewise, this F1 also I can take two components, F1 x component, F1 y component. F1 x component is 5 Newton, therefore F1 y component is another 5 Newton in the upward direction. You can see here 5 Newton to the backward direction, 5 Newton to the forward direction will cancel off each other. 5 Newton in the upward direction, 5 Newton in the upward direction. That will be 10 Newton in the upward direction. This 10 Newton will be balanced by this 10 Newton. 10 Newton in the upward direction equal to 10 Newton in the downward direction. Therefore, I can say that this body, this object is in equilibrium. Now we'll see the second one. Under third category, what are the conditions to be applied? Three forces must be coplanar. That is correct. Line of action of the three forces must meet at a common point. No, it's wrong. Here, this is the line of action of force F1. This is the line of action of force F2. This is the line of action of force F3. Line of action of force F1 and F2 meet each other, but line of action of force F3 does not meet at this point. F3 does not meet at this point. Therefore, all F1, F2, F3 will not meet at the same point. F1 and F2 will meet at the same point. F3 will be at a different point. Therefore, this is not in equilibrium. We'll see the third one. Three forces are coplanar. First one correct. Second one also correct. Now we'll see the third one. Here you see, here, they have said F1 is equal to F2. No. Let me take F1 as 5 Newton. And F2 is also 5 Newton. F3 there is a different value. If F1 is equal to F2, now if body is to be in equilibrium, two conditions must be satisfied that you should know. Resultant force should be 0. Resultant moment should be 0. Here you can see F1 force will be cancelled by this F2. F1 5 Newton in the backward direction, F2 5 Newton in the forward direction. This F2, this F1 will cancel off each other. But you can see there is a force acting in the downward direction. But there is no any force in the upward direction. So what will happen to this box? This box will move down. This F1, F2 will cancel off each other. F3 will be acting downwards. There is no force in the upward direction to balance this. Therefore, the object will fall down. Therefore, the resultant force is not 0. Therefore, this is not in equilibrium. But here you can see here, the 5 Newton will cancel off each other. The downward force F3 will be balanced by the upward force created by the component of F1 and F2. Therefore, these two will be balanced. These two will be balanced. The resultant force is zero. This and this will balance. This and this will be balanced. Resultant force will be zero. This object will be at the same point. Here, yeah, I said, they are not in, the points are not meeting at the same point. Here also, you can see if the first condition is satisfied, second condition is not satisfied. They are not meeting at the same point. If I extend this F1 and if I extend this F2, if I extend this F3, you can see F1 and F2 are meeting at the same point. F2 and F3 are meeting at the same point, but all three forces are not meeting at the same point. Like this, all three forces are not meeting at the same point. Like this, all three forces are not meeting at the same point. Here, these two forces meeting at one point, F3 and F2 meet at a different point, but all F1, F2, F3 does not meet at the same point. Therefore, it's not in equilibrium. If they give like this in equilibrium question, you should see which type of category, under two forces category or under three forces category. If it is under three forces category, look at the conditions. See the conditions. If the conditions are applied, then in equilibrium. Condition, if either one of the condition is not applied, then they are not in equilibrium. That's it. And also, if a body is to be in equilibrium, resultant force should be zero, resultant moment should be zero. Okay, that's it. Those are the points that you should consider when approaching equilibrium question. So I'm going to clean this. Any important points, you can note it down. 2018, fifth question. See the question, 2018, fifth one. First choice, the resultant force of two forces should be in the same direction as that of the remaining force. In the three forces, the object is in equilibrium. The resultant force of two forces should be in the same direction as that of the remaining force. No, it should be in the opposite direction. Now, if F1, F2, F3, the resultant of F1 and F2 should be equal to F3 but in opposite in direction. Resultant of F1 and F2 in the upward direction. The F3 should be in the downward direction. Resultant should be in the upward direction. Resultant of F1 and F2 in the upward direction. F3 in the downward direction. And R should be equal to F3. This is what it is. But it is said resultant force of two forces should be in the same direction as that of the remaining force. No, this is wrong. The resultant force of the three forces should be zero. Yeah, that's correct. The third one, three forces should be coplanar. Three forces must be coplanar. Fourth one, line of action of three forces should meet at the same point. Under three forces, there are two categories. You see, this is one category. If they are on the same plane, AF3, AF1, AF2. But they have said that the three forces should be coplanar. Three forces should be coplanar. That should also be correct, right? 2018. If an object to stay in equilibrium under three forces. Equilibrium probability under three coplanar parallel forces. Condition to be satisfied, three forces must be coplanar on the same plane. The one force must be opposite in direction to the other two forces. Third condition, resultant of any two forces must be equal in magnitude and opposite in direction to the third force. That is equilibrium of a body under three coplanar parallel force. If equilibrium of a body under three forces that are not parallel, three forces must be coplanar. Three forces must be coplanar. I think third one, three forces should be coplanar. Is to stay in equilibrium under three forces. The line, this is the fourth one. Line of action of the three forces should meet at the same point. For this, it's correct. For this, the second should be the answer. Fourth one, for this condition, it's correct. F1, F2, F3 should meet at the same. But here, it's not the condition. F1 is this line of action, axis of rotation. This axis of rotation. Line of action of force. This line of action of force. This line of action of force. This line of action of force will not meet at the same point. Will not meet at the same point. Therefore, in that sort of a case, it's wrong. Fourth statement is wrong. Because they have generally said under three forces. They haven't said three coplanar parallel forces or three non-parallel forces. They haven't said. They have just said three forces. Three forces mean you can consider both the instance. Therefore, fourth will not be the answer. Fourth is wrong. Third one, three forces should be coplanar. I'll check that and tell you. 2018. Three forces should be coplanar. Answer given is second one. However, that's correct. Resultant force of three forces should be zero. That's correct, no? For an object to be in equilibrium, Resultant should be 0. Resultant force should be 0. Resultant moment should be 0. Therefore, if the resultant force is 0, then the object is in equilibrium. That's correct. But third one, I will check and tell you. 2018, fifth question. Third one is doubt. But they have given any choices, one and third likewise. Therefore, I'll tell you in the next class. We have given 2018, fifth one, second answer. Okay. Now let us move to 2023. 2023, 31st question. Figure A, B, and C show how coplanar forces are applied on three rectangular sheets of the above sheet in equilibrium. Of the above, the sheets in equilibrium. Here you can see 5 Newton, 5 Newton, 10 Newton in the upward direction, 10 Newton in the downward direction. They are opposite in direction, equal in magnitude. So resultant force is 0. Therefore, this is in equilibrium. Therefore, A will correct. B. Coplanar forces are applied on three rectangular sheets of above the sheet in equilibrium. B is also correct. Three forces are acting. They are same plane. They are on the same plane, and the line of action of forces will meet at the same point. The resultant of two forces is equal to the other force. Therefore, B will also correct. C, it's not correct because C, if you take here 5 Newton here these under the two forces condition, right? Equilibrium under two forces. If the object is to be in equilibrium under two forces, what is the condition? Two forces should be equal in magnitude. Two forces should be in opposite in direction. The line of action of forces should be same. But here, this line of action, this line of action. Therefore, not. 2023, A and B is the answer. Oh, B. A is correct. B. ABC show how coplanar forces are applied on three rectangular sheets of the above the sheets in equilibrium. B will not be the answer because I said you here in the earlier question, if this is 10 Newton, all the forces should be same. Here, if one I marked as 10 Newton, F2 also I marked as 10 Newton. You have noticed this in the earlier question. The earlier example I discussed. If this is 10 Newton, 10 Newton, 10 Newton. So what will happen? This 10 Newton will be divided into vectors. 5 Newton. Here also 5 Newton, 5 Newton. This 5 Newton and the y component 5 Newton. 10 Newton will be classified as x component, y component. 5 Newton, 5 Newton. Therefore, B will not be the answer. Remember, when three forces are acting on the body like this, all three forces should be equal in magnitude. Then only the resultant force will be zero. Here it's given 5 Newton. Yeah, this 5 Newton, 5 Newton, 10 Newton. 5 Newton means when they classify, there won't be, yeah, when they classify, if it is 5 Newton means, 5 Newton means, here it will be 2.5, half of it, and here it will be 2.5. Likewise, 2.5 will be 2.5 here, 2.5 here. Altogether, there will be 5 Newton in the upward direction. Down 5, up, down 10, up 5. Therefore, resultant force will be 5 Newton in the downward direction. This object will come downward. It will move downward. Therefore, B is not the answer. Only A. A is the choice. Therefore, 2023, 31st, answer number 1. Equilibrium MCQs are done. 2018 question, I will check and tell you. That's it. I'll finish off the class.